Thank you all. Thanks for coming. I hope you can all hear me okay. So the talk is ranked choice voting for lovers, haters, and prognosticators. And we'll get into all of that. Some of this talk is based on a bit of new research that I did with our colleague, Professor Nick Kapoor, who is too tired because he was up all night working on the election. So I will let you know when the work with Nick comes up. So we're going to talk about lovers, haters, and prognosticators, about ranked choice voting. Ranked choice voting, I'm going to write RCV, is a new kind of voting here in the U.S., although actually it's not new in the world at large. But in the U.S., it has recently been adopted for certain places. In particular, in Maine and Alaska, they use ranked choice voting for all of their elections. We got plenty of seats down here. Thanks. It's used locally in other places, like the local elections in New York City use ranked choice voting, and some other places also. And the idea, in case you're unfamiliar, instead of voting for just one candidate on your ballot, you get to rank your choices. For example, this is a picture of a real ballot that was used in Alaska in 2022. That was the first time that they used ranked choice voting for their big elections. And this was the election for U.S. representative. And here you can see you get three different options: Begich, Palin, and Peltola. And your vote consists of scribbling in the circles here about who's your first choice, who's your second choice, who's your third choice. So a typical vote would look something like this. This represents someone who they think Peltola is their best candidate. And then their second choice is Begich. And they listed no third choice. This is also legal. So when you're voting in one of these elections, you don't have to rank all of the options. You can, because let's be honest, usually when you go to vote, if there's like 10 options there, you only really care about 2 or 3 of them. Probably, in my case, it's usually just 2 of them, right? And so you don't have to rack your brain trying to rank all those other guys you never even heard of. You can just rank the ones that you care about. So this vote means I think Peltola is the best. In case Peltola doesn't win, I would like my vote to count to Begich. And in case Begich and Peltola both don't win, then you shouldn't count my vote for anybody. So because I didn't write Palin in for my third choice, that means I don't want my vote to count for Palin under any circumstances. That's what this kind of a vote means. By the way, feel free to interrupt with questions if you got any. The big question, I hope that this sounds, a lot of people hear this and they're like, oh yeah, that sounds like a great method. Actually, I haven't really told you the method yet, because the real meat of the method is, how do you actually count up the votes like that? If you receive a bunch of these votes, let's say I get like 10,000 different people's rankings, how are you going to actually combine them together to get a winner? You can't just just add up the votes. It doesn't really work that way, because everyone has a first choice, a second choice, a third choice, and so on. Anyway, in the ranked choice voting procedure, you do this in elimination rounds. So in round 1, you count everybody's first choice, and you kind of see what happens. In this election, I got the numbers here. In this particular election, if you count everybody's first choice, you see Peltola got that many, and Palin and Begich got far less each. Now, this looks like a blowout, but actually you shouldn't consider this to be a blowout. This happened because Palin and Begich are in the same party. They were both Republicans. And so you would ordinarily expect, if there are 2 Republicans on the ballot, they would more or less split the Republican vote even. So how do we get past this? Now we eliminate the loser, and then you redistribute the second choices. So Begich here is the loser, and that means we're going to throw Begich out of the race, and all of the people who voted for Begich as their first choice, we're going to look at their second choices, and then those will be counted for whoever it is. So in this example, these are the real numbers. The people who voted for Begich, this many, 13,000 of them, had no second choice. This many had their second choice as Palin. This is not surprising, that because these are the 2 Republicans. So you would expect a lot of the Begich people to also like Palin. And then you have very few people who wrote Begich first and then Peltola second. That's because these are opposite parties, so you would expect not a lot of people said that. All right. Like I said, the people who gave no second choice, we throw those votes away, because remember, when they voted, What they meant when they said, I like Begich and nobody else, that means Begich is my first choice, and I do not want you to count my vote for anybody else. So we throw those votes away. We add the other two to the previous round one totals, and now this is the final result of the election. Between these two, Peltola is the winner. Right? This is how the ranked choice method works. I hope that made sense to everybody. It's fairly, it's a little complicated, but it's not too complicated in my opinion. Yeah, once you get down to two candidates, then you just count the votes up in the normal way. All right? Peltola won this election. She served as the representative, since 2022. All right, so the basic idea, to summarize, you count everybody's top choice. You eliminate whoever got the fewest votes. And then if your favorite was eliminated, then your vote gets to count in the next round using your second choice. All the people who voted for the person who got eliminated, their second choices count in the next round. Or if they had no second choice, then their votes don't count anymore. All right? And you repeat these eliminations until somebody wins. So I did this for 3 candidates. You need 2 rounds to finish, but you can do it for any amount of candidates. You just throw away 1 person each round and eventually get down to 2, and then the election is decided. All right? What I like about the ranked choice is that ranked choice is a great way to run an election between more than 2 candidates. Like our traditional system, where everybody just votes for your favorite, is actually really bad at handling races with more than 2 candidates. The traditional system gives a huge disadvantage to any third candidate on the ballot. If you have 2 major parties and then some other guy, basically nobody is going to vote for the other guy because you're only allowed to give 1 vote, and you want to make your vote count. And kind of everybody knows this. If you vote for the third party, a lot of people do this for various reasons, but mathematically speaking, your vote is not going to be counted in the sort of true meat of the race that you're voting on. All right? This huge disadvantage to any third candidate basically locks us into the 2-party system. If we already have 2 dominant parties, which we already do, this means from now on forever, nobody's going to vote for the third guy. They're always going to vote for one of the 2 parties. And a lot of Americans say what are you going to do? It's just a 2-party system. I would say we do have a 2-party system here, but part of that is because of the way that we do voting. And it doesn't have to be that way. If we voted in a different way, we wouldn't have this sort of permanent 2-party system. All right? Ranked choice voting removes this systemic lock, like the system that we currently use. The traditional system, not the ranked choice. That really locks us into the 2 parties. And if you change to ranked choice, it does at least something to alleviate this kind of lockage. And as you can imagine, there are lovers and haters. So here's a picture of the lovers. I've heard that you should just have random pictures every so often in a presentation like this, even though I feel, in my opinion, this picture doesn't really add a lot. But these are people who love ranked choice voting. And here's what the lovers say, all right? With the ranked choice voting, the voters are able to express more nuanced opinions, right? And in particular, you don't need to worry about throwing your vote away on an outsider. That's because your second place can count. So actually, if you're voting in a ranked choice election, it means you can, if you want to, vote for that third guy. Even if you think that third guy is going to lose, your vote is still going to count for your second choice after that guy gets kicked out in the first round. All right. One slogan that the ranked choice people say is, "You can vote your hopes, not your fears." Right. A lot of people voting in our traditional system are casting a vote not because they love the person they are voting for, but because they really hate the person that they're not voting for. And you're trying to vote against somebody by voting for the other guy. If you're using a ranked choice system, there is more opportunity, so the lovers say, more opportunity to actually vote for someone you really like, even if you don't think that that person is capable of winning the election, because you can still list your second choice as a backup, all right? And they say even if your favorite loses in round 1, your vote still counts for your second choice. This is what everybody loves about ranked choice voting. All right. Another nice thing about ranked choice voting is the candidates want your vote, of course they do, but in a ranked choice system, the candidates also want to get your second place vote. And what that means in practice is the candidates have less incentive to be negative towards their opponent, all right? It means that in an election, if you're a candidate running in a ranked choice election, You can say stuff like, I'm the best choice on the ballot and I'm better than these other guys. But you shouldn't say something like, I'm the best choice and anybody who votes for the other one is an idiot. Because then those other people, they won't like that you called them an idiot, and they're not going to put you as your second choice, all right? But you want to, if you're a candidate in one of these elections, you want as many people, of course, to write you as their first choice, but you don't want to upset anybody anyway. Because you're hoping that they'll throw you a bone and put you in second place, even if they don't like you in first place, all right? In general, it is believed by the lovers that this will cause our politics in general to be less negative and more positive. This is one of the kind of promises of the ranked choice system. All right? I think the most sort of concrete thing about ranked choice, in my opinion, is it makes legitimate three-way races possible. I would say the system that we traditionally use in the U.S., of course, you can have more than two candidates on the ballot, but it's not really a fair competition when you have more than two candidates and two of them are in the two major parties, right? With the ranked choice, what this means is, in the long run, the ranked choice will reduce the lock of the two-party system, which, a lot of people casually say, oh, I hate the two-party system. Although, of course, depending on who you talk to, this is either a good thing or a bad thing. Some people are lovers of the two-party system. So this is sort of controversial as far as, is that a good thing or not? All right? What about the haters? There are ranked choice haters. These are some anti-ranked choice things. This is from an outfit called SetAlaskaFree.com. Alaska is currently living under the tyranny of ranked choice voting, and there are a lot of people who don't like it. In my opinion, I would say a lot of the haters' arguments are what I would call vibes-based. I think this is a little unfortunate for the anti-ranked choice movement. To me, a lot of the anti-ranked choice stuff is just not convincing at all, and I'm not trying to be partisan about it. But anyway, here's a quote from Sarah Palin, who lost that ranked choice election. She said, when it comes down to second and third place votes, that's going to decide who wins? I mean, really? To which my response to Ms. Palin is, yes, really. That's just how the system is supposed to work. Here's another one. The Alabama Secretary of State, there was some discussion about ranked choice in Alabama. He says, ranked choice voting makes winners out of losers. This is because it is possible to not come in first in the first round, but then win in the second round because of the second choices. And some people are like, what? That's crazy. How can you not win the first round, but then you do win the second round? Isn't that crazy? To which I would say, I don't know, it's not that crazy. That's just how the system works. The Heritage Foundation is a famous sort of super conservative think tank. They say this is a little more precise, in my opinion. Ranked choice eliminates genuine binary choices between two top-tier candidates. So there are a lot of people who say voting in the United States should always be about two candidates, and you choose one or the other. That's the way it ought to be. To me, my immediate question is, why do you think it should be that way? But a lot of people have this opinion. There should be two choices, and I should just choose one or the other. I should not say who my second choice is. I don't know why, really, but here's the basic vibes. Voting should always be between two options where each voter only chooses their top choice. A lot of people believe this. There's another quote from this Heritage paper. They wrote a paper about ranked choice voting. Your votes are thrown into a fictional fantasy. Palin said that ranked choice voting is crazy, convoluted, and confusing. Now, I don't really think it's all that crazy, but this is actually a legitimate problem. If the voters are not able to understand the system that they're using, then I don't think you'll get a meaningful result, right? To me, there is something undemocratic about using a system which is so crazy that nobody is able to understand it. Now, I don't actually think that ranked choice is that crazy, but this is a legitimate concern that people have. If voters don't understand the system, then we probably shouldn't be using it in a democracy. In my opinion, it's not really that complicated, all right? Here's my own opinion, in case you care. I think ranked choice is a good system to use. Nobody has to rank their choices, but you can if you want to. I like the idea of as a voter, being able to express a more interesting opinion, just rather than saying, I like Trump or I like Harris. I think it's better if you let the voters express their opinion in more sophisticated ways. But I'm not much of an advocate, I'm not like an activist about this. I think actually there are other ranked voting variations that I like better than this ranked choice system. But I do think that it would make our politics a little bit better, and I would be happy to argue with any of your hot takes afterwards at dinner if you like. Unfortunately, it has turned into a bit of a partisan issue. Generally, the Democrats like ranked choice and the Republicans dislike it. But in my opinion, there's not a great reason for that. Like, there's nothing specifically liberal or conservative about these voting methods. There's nothing Democratic or Republican about the method. It's just a mathematical method. I don't know if you were paying attention, but the ranked choice was actually on the ballot yesterday in several states, and I looked up the results of this. In the state of Idaho, these were ballot measures that, everybody voting for president also voted yes or no on these questions. In the state of Idaho, there was a question about should we switch to ranked choice voting in the state of Idaho? The result? No. They said no. So Idaho will not be changing to ranked choice voting. The state of Nevada had the similar question. Should we change to ranked choice? Also no. The state of Oregon, should we change to ranked choice? Also no. This was a bad night for the ranked choice lovers. The state of Colorado, should we change to ranked choice? No. The state of Missouri, this is interesting, they had a ballot measure that will preemptively prohibit the ranked choice. So they weren't using it, but they're like, hey guys, just in case, we want to make sure we're never going to use it. And this is a little sneaky. They bundled this with a specific declaration that non-citizens are not allowed to vote, which of course is already the case. This one passed, though. So now in Missouri, it is illegal to do ranked choice voting and sort of extra illegal for non-citizens to vote. It was already illegal, but I think that was a bit of a sneaky move there. CD, sorry, that was supposed to say DC. The city of Washington, D.C. also voted to switch to ranked choice voting. That one actually passed. So that means in Washington, D.C., all of their city elections, and they also have some kind of representative in the Congress. Those elections will be done now using ranked choice. The state of Alaska, a lot of haters in the state of Alaska actually got a question on the ballot to switch back from ranked choice back to the ordinary system. This actually, I've looked up the numbers. It seems like this is going to pass, but the numbers are not all in yet. So I'm going to say this one is still unsure. All right. I would say the haters had a good night on this one overall. All right. Now, I said before, I kind of like the ranked choice voting, but the ranked choice voting ain't perfect. Remember, and if you are a ranked choice hater out there, any of the Heritage Foundation folks, I would encourage you, stop with the vibes. There are actually legitimate concerns to be had about ranked choice voting, and I'm here to show you one. In this election in Alaska between Peltola, Begich, Palin, remember these were the original votes. I left out the numbers, but those are the bars. And I would like to encourage you to look at the second choices for the Palin voters. So we have a bunch of Palin voters who wrote no second choice. This is first choice Palin, second choice Peltola. That's almost nobody because Peltola's a Democrat and Palin's a Republican. And then this is Palin, second choice Begich, which is a lot of people because Begich was another Republican. All right? Does anyone see anything weird about these bars? It's not actually easy to see just by casually looking, but something very weird happened in this election in 2022. I would like to look carefully about who of the voters likes Peltola versus who likes Begich. So if you just temporarily forget about Palin, but just look at Peltola and Begich, compare the opinions. And I have made some colors here. The purple people are the ones who liked Peltola better than Begich. That, of course, is everyone who voted Peltola first liked Peltola better. And then these people voted Palin, then Peltola, then nobody. So we can assume that they liked Peltola better than Begich. And these green people, they liked Begich better than Peltola, right? These people who put Begich first, obviously they like Begich better. And then these people who put Palin and then Begich second, they also like Begich better than Peltola, all right? Do you notice anything weird now? Any thoughts? Yeah?
Begich has more support.
Yeah, the green is more than the purple. If you sort of line these guys up across all the voters, more people like Begich than Peltola, all right? This is a true fact. I'm not making this up. When they did this election, a majority of the voters liked Begich more than Peltola, all right? But Peltola was the winner. This, in my opinion, is messed up, and this is a reason to be a ranked choice hater. although none of the ranked choice haters say this. I think it's because this is a little complicated to understand, and it's hard to make sort of like a 5-second soundbite about this. But this, in my opinion, is a real issue. The ranked choice method with the rounds and everything does not actually measure all aspects of the voter preferences. In this case, the problem is there was never a round, just one-on-one, Peltola versus Begich. The only one-on-one round that actually happened in the election was...
I don't understand. I didn't understand. I'm sorry. So can we go back in the previous slide?
Yes.
Sorry. So are you saying before, right, those colors, it was the one that was counted the second round?
Yeah.
Indicating second choice?
Yes.
Like when you say, so we had the runoff, and then we counted the second choice of Payton, and then we added that?
So in the way that the election actually happened,
Yeah.
Begich lost in the first round.
Oh, that's right.
And his
Right.
votes
Oh,
were
sorry,
redistributed.
sorry. Yes,
So in the election,
Oh,
as it actually happened,
thank you.
they never even split this out because there was no. The problem is in the real election, there was never a round between Peltola and Begich.
Right.
The only round that actually happened was between Palin and Peltola.
And since I interrupted everybody, I have another question.
Yep.
Do you ever go to the third round?
If you had 4 candidates,
Oh, okay.
yeah, you always eliminate 1 candidate per
Yeah.
round. Yeah. So if you have many candidates to begin with, you have to do a lot of rounds. But all the rounds, the rounds are all done in a computer, so it's not like you actually vote again. Yeah.
Is this what some critics call exhausted votes?
So the exhausted votes are these people whose votes, who wrote no second choice, their votes will not be counted in the next round, and that's called exhausted votes. Yeah. This also, the haters get all upset about the exhausted votes. To me, this is a bogus thing to be a hater about, because the people who voted in that way, they chose to vote in that way. You might say they didn't know what they were doing, and that would be a real concern, but as far as a limitation of the system, to me, this is not a big deal. Anyway, can I just say, yeah, in this election, the issue was there never was a round, Peltola versus Begich, and so those opinions that people had, they didn't come up in this election, all right? This is what I mean by, I said the ranked choice does not measure all aspects of voter preferences. This is an aspect of the preferences which was ignored. The ranked choice procedure never sort of realized that people actually like Begich more than Peltola. All right. But I would say, I said this is actually a decent reason to be a ranked choice hater. But I would say don't get too excited, haters, because what I'm talking about is a nuance of the preferences. Of course, if you're doing traditional voting where you don't rank any of your choices, there's no nuance at all in that system. So our traditional system has the same problem, and I would say it's even worse in our normal system. The exact same limitation also exists in traditional voting. All right, so anyway, the moral of this little story is ranked choice elections can be hard to analyze, and if you look at the results after the fact, often you have to kind of look very closely and often sort of in weird ways to understand really what was going on. All right, so let's get to the prognosticators. This is a bit of new research, like I said, that I did with Professor Nick Kapoor about predicting ranked choice outcomes based on probabilities. This is hard, in my opinion, but of course you want to be able to do this as ranked choice becomes more popular. So I wrote that line before ranked choice was defeated in 7 different referendums. But ranked choice voting, it's still being used in some places, and who knows what's going to happen in the future. It may become more popular than it is now. But if you want to have people, doing news articles about who's going to win the election, they have to know how to do that in a ranked choice system. And actually, everything is different in a ranked choice system when it comes to making predictions like that. I thought maybe it would be interesting, I hope you won't mind, this little behind the scenes of how this research project went. I thought it might be fun to just kind of give, this is mostly for the students, a little impression about sort of what it is like to do a new mathematics research project, or like what it even means to do math research in this way. So this is sort of a little story of how this project happened and how it came to be. My dear friend Nick Kapoor had the basic idea. He knew that I was kind of interested in voting methods, and he came to me once and said, hey, you want to do some kind of some kind of new research about ranked choice voting, and I was like, yeah, all right, sure. We had our first real meeting to discuss this was in October of 22, so that's a little more than 2 years ago. And he asked me, do you think it's possible to predict the outcomes of a ranked choice election using some kind of statistics, probabilities? And this was the basic question that the paper ended up being about. And to me, this seemed like a decent idea. It seemed like it might be complicated, but I thought maybe we could work something out. Actually, I became interested in other things. And at first I was trying to convince him, like, hey, wouldn't it be cool if we talked about this and this and this and this? This is kind of like when you're doing a project like this, and maybe, I don't know if you've experienced this just as a student doing group projects or something, interest and timing is important. This is a bit like, he's not here now, so maybe you wouldn't mind the analogy. This is a bit like dating, maybe. It's like you have to be interested in each other, but you have to be interested in each other at the same time and at a time which is convenient for the both of you. Like I have enough free time to invest some time into this other thing that I wasn't doing before. That actually is a huge part of sort of negotiating a successful research project, is kind of working that out. So after these talks, both of us got really busy with other stuff, so we didn't really do much in that fall. We met up again seriously in April of 23. I had some really big ideas. I was like, oh, this is going to be great, Nick. I got this and this and this theorem that I know how to prove. And then all of those ideas were wrong. Within a couple weeks, we had decided that all of my ideas were bogus. And he was like, hey, what about that predicting the outcomes of ranked choice? And I was like, yeah, maybe that is a good idea. So he ended up going back to his original idea. This is actually pretty typical for me when I'm doing a research project like this. I have lots of bad ideas, and this is just like part of doing mathematics in my experience. You can talk to your other math professors and see if they have similar experience, but this is how it goes for me. Typical meetings, we conveniently work at the same university, right? So we could get together here. We would just kind of like sit around for a couple hours talking aimlessly about stuff. This is typically how a kind of working session would go. There's sort of an emotional roller coaster that you probably experience on a small scale, like when you're doing your math homework. You first look at it and you're like, I have no idea what this is all about. And then you got to work through it, and eventually you figure things out. It's kind of like that, but you stretch that feeling out for like 2 years. And it's kind of a cycle of like, I have no idea what this is about. And then you're like, oh yeah, okay, I think I figured something out. And then you're like, oh, no, I really don't understand that at all. And it goes back and forth. You start off kind of confused. You work and think about it a lot, and eventually you figure it out. And then you repeat the cycle for months and years on end. That's sort of how it goes. Often you think you figured it out when you really didn't. I know for students this can be very frustrating. I think I have, I guess, learned to understand that this is like the way that the process goes. So I don't find it all that frustrating just because I'm used to it, but it is kind of demoralizing at times. Anyway, we settled into this specific question around June 2023, so like a year and a half ago. And by July, we had like the basics of what I'm going to show you, our basic approach to the whole thing. We wrote up some code about it because this is an algorithm. And by that fall, we ended up rewriting the whole thing because this often happens like your first crack at it, even if your first idea ends up being more or less right, once you really figure it out, you look back and you realize, oh, okay, I should have said everything totally differently. Once you figure stuff out, it makes you rethink stuff all the way from the beginning. Anyway, in October and November of last year, I had another big idea related to this project, but I spent about 2 weeks working like 3 or 4 hours a day, and I wrote a bunch of new stuff into this paper we were writing. All of this eventually got deleted because it was all bogus. Anyway, by spring of this year, it was mostly settled. There are still a lot of things about the project that we don't understand. I mean, further questions that we are considering that we don't have answers to. We had arguments about the introduction. I didn't like some stuff that he did, and he didn't like the way that I was writing it. Just complaints about the writing. We changed the title at the last minute. This is all typical stuff. Anyway, we finally finished the whole paper in May of 2024, just after our exams. We sent it to a journal to be published, and that process is still ongoing. This takes a long time for for that whole process. And I don't need to get into that, but if you're interested in the whole publication process, I'd be happy to share it with you. This is the paper. Here's another a little math culture moment. You can see the way that I wrote the paper is Kapoor and S for Stecker, that's me. Publications in mathematics are almost always written with the authors in alphabetical order. This is not true in the sciences generally. Usually the ordering of the authors tells you how important each of them are. But in mathematics, we're so humble that we are going to put them in alphabetical order at all times. This means, I've published many papers with with collaborators, and I've never been the first author because my name starts with S. Another little cultural thing. I don't know if this is true in all of mathematics, but I was taught by my advisor, when you give a talk that references your own work, you should not say your own name, and you should not even write your own name. So I wrote S to indicate my name, and when I read this, I just violated this principle. But I wouldn't say Kapoor and Stecker. I would say Kapoor and me, or something like that. It's viewed as somehow like low class to say your own name in a talk about your own research. I don't know how universal that is, but the people that I roll with, I definitely feel that way. Okay, anyway, let's talk about some of the content of the paper for about 15 minutes or so. Predicting elections is what I want to talk about. That's what the project is about. So if you have a traditional election between only two choices, you can do some kind of polls to get a guess for how you think people are going to vote. And there will typically be some amount of uncertainty in your guess. And one of the simplest ways you could write it is somehow like this. So this is my main guess, but this is kind of like the uncertainty in how many votes I think that person is going to get, A and B. And looking at that, can you tell who is more likely to win? Well, I would say, first of all, I'm predicting that A will get more votes than B. So probably A is going to be the winner. But actually, if you do a little bit of fancier statistics, you can predict with more specificity. Can we predict the outcome? This situation is very well understood mathematically. I say easy just because, there are formulas for working with a scenario like this that people don't have these memorized, but you can go look it up, right? And this is very easy to handle. If you assume that the votes are arranged, these kind of uncertainty is arranged according to independent normal distributions, which I'll say a little bit more about that later, then you can actually just straight up calculate the probabilities of each of these candidates winning. And in this case, you can calculate A is going to win with probability 81%. 81! I should say 91. These should be adding to 100. Sorry, I never noticed that before. Yeah, anyway, you can, this is all, I say easy when I messed it up, but this is all well-known stuff, and it's easy to do, all right? The calculation that you have to do here is super fast. In fact, it's so fast that you can redo this calculation several times per second. And similar type calculations have led to, this is the famous New York Times election needle. This is an old version of this. This was from 2016. I got this animation. They had this little thing on their website where moment to moment they were recalculating their predictions of who was going to win the election. And as you can even do this sort of live as you're counting the votes. Every time you count a new vote, you rerun your little prediction, and it gives you moves the needle a little bit, right? Anyway, our goal is to do the same thing for ranked choice elections, and this is how actually Professor Kapoor suggested the project to me to begin with. He said, I want to make a needle for ranked choice elections, which is a more complicated probability type calculation. This immediately becomes much harder, all right? Let's imagine we have three choices, A, B, and C, and we're trying to calculate. Here's what it ends up being. Really, if you want to calculate the probabilities that various people will win, you first need to figure out the way the rounds are going to go. So if I have three options, first I have to figure out what's the chance that A will be eliminated in the first round and we go to a round between B and C. And then once we get there, what's the chances of B or C winning? There's a lot more going on in a picture like this. We're trying to calculate all those probabilities. We call this a weighted elimination tree. So this is a tree. This is a mathematical structure called a tree because of the way the branches go and all that. And it's called a weighted tree because each of the branches has a probability associated with it. All right. And the set of votes that you're looking at is also far more complicated than in the traditional voting. We would start off with votes, but like before I said, A is something plus or minus something, B is something plus or minus something. What about A versus B versus C? You get actually 9 different categories of votes depending on who people's second choices are, all right? So you have to somehow take all of this business and do something to it to turn it into probabilities in that big tree, all right? And actually, it's a little worse than that. This type of data, really for real life, is not specific enough. Because, for instance, 72 plus or minus 4, this means basically 72 is the most likely value, and then some other values nearby are a little bit less likely. But it's unspecific right here about exactly, like, for example, exactly how likely is it that they would get 73. This doesn't really say. It just says the possible values are between, I suppose, 68 and 76, right? Just giving a range like that doesn't express enough information. So what we're working with in our algorithm is big tables of data like this. And the way you should read this is, for example, here's first choice C, second choice A, and like this 37%, 0.37, it means the probability that this option gets 200 votes is 0.37 or 37%. All right. So all of these probabilities together tell you how likely various vote totals are for this particular vote. First place C, second place A. All right. And if you want more precision, I'm here grouping these in categories of 100 votes each. Those we call the vote buckets. That's not terribly precise, but if you want more precision, you do this with more buckets. Here there are, I guess, 6 buckets. When we run our actual algorithm, the code that we wrote uses 1,500 buckets every time, which seems to be a fairly decent amount of precision. All right? Anyway, we want to fill in all of these numbers here. And the ones on the right side are easy because these represent probabilities between only 2 options. And everybody already knows how to do that. So those ones are easy. It's the ones on the left that we have to focus on. These we call the elimination probabilities. The one on top is the probability that A is eliminated in the first round, and then similarly B is eliminated in the first round. That's the next one, and so on, right? So if you are looking at a big chart of votes like this, given all of that, what is the probability that A is eliminated first? And this is, it's not obvious what to do with all of these numbers to come up with what I'm looking for. But it has to do with who gets the fewest vote totals in the first round. That decides who gets eliminated, all right? So who gets the fewest vote totals? If you want to know what's the vote total for A, for example, in the first round, the votes for A are grouped into these 3 categories, and we have to add them together, all right? That will give you the total number of votes for A. But we can't actually add them together in the normal way. Like here, if I'm looking at only the votes with A in the first position, we have these probabilities, but you can't just add the columns up. That doesn't make sense, actually. Like, for instance, if you add the columns sort of horizontally, this one adds to more than 100%. So that already, something is messed up there, all right? That's not the appropriate way to do it. You can do it, but you'll get bogus answers. The correct way to sum these kinds of columns of probabilities is like this. These are weird numbers which are calculated using these over here, and there's a special operation for this. This is called the convolution, and it is the way to add together 2 probability distributions. So there's like special math that you have to use in order to add together columns of probabilities in that way. If you have 2 probabilities, the distribution for the sum is given by this operation that we write with a star, and that's called convolution. And this is the definition of the convolution. It involves doing a somewhat weird, a bunch of multiplying, and then you add up all of the answers. I don't need to get into the details, but this is a special kind of operation. And there is a fast Fourier transform-based algorithm for this. So this sum, if you just do this sum by hand or as written, it's not very efficient, but you can do this far more efficiently. The complexity is log of B, where B is the number of buckets, the number of rows in the table. So actually this step, once you figure out how to do it, is actually computationally fairly efficient. So anyway, the procedure for finding these probabilities we're looking for, first you do convolutions to combine the votes for A in the first round, B in the first round, C in the first round. These are probabilities for each candidate's total in the first round. And then you do this thing. So this is a formula that we came up with. What this means is the probability that A is eliminated is the total vote count for A times these, this is the probability of A getting a certain number of total votes. These are probabilities of B and C getting more votes than that. And so what this gives you is sort of the probability that A got a certain amount, but B and C got more. That is to say A gets eliminated. All right, that's a little complicated. Anyway, for this example, you can go through the sums and whatever, and you get these as the answers. And I believe those answers are correct in this one. They actually add up to 100%, which makes me feel good about them. All right, so that means that given this data here, the probability that A is eliminated in the first round is 74%, and so on. All right, and then you can fill in the whole table here. So we can fill in the cute tree from before. I made it extra cute by the thickness of the lines here is according to these probabilities. So if you look at the thickness of the line, you can see the most likely scenario in this example is A will be eliminated first, and then B will be the winner. Sort of second most likely would be C is eliminated first, and then B will be the winner. All right, and other things are less likely. I kind of like the way that this looks. This is it's an interesting way of visualizing things, and to me, it's very satisfying that we were able to actually figure out how to do all the computations. Overall, these are the winning probabilities for that example there. All right. Here's just to show you how impressed I am with my own pictures. This is a picture with 4 candidates here. We had 4 at the beginning, and then there are 4 possible eliminations here, and then they each go into these further eliminations. It gets a little complicated, but this is what it looks like, and it totally works. All of this runs pretty fast on a normal computer. Like those examples right there, I was running just on this very computer right here. If you have only 3 or 4 candidates, it takes under 1 second to do that, which is good news. For 5 candidates, it's 14 seconds, which is not great. For 6 candidates, it's 5 minutes, and it gets worse from there. That's because the complexity, if you have more and more candidates, the tree grows in a factorial way. And so we expect you essentially couldn't possibly do, using our methods, you could never do, say, 10 or 11 candidates without some serious new approach. It becomes unreasonable after that, all right? But anyway, for 3 or 4 candidates, it is fast enough to calculate in real time, which means you could use this as some kind of a needle. Here's an example of, and this is a picture that appears in the paper. This is a simulation of a live sort of election night calculation where you imagine as you are counting the votes gradually, moment by moment, you are making new predictions every time you count some more votes. And what you can see here is, so towards the left side, this is the percentage of votes. So when you've counted none of the votes, basically you don't have any idea of who's going to be the winner. As it moves to the right, it seems more and more clear that this line, this guy, which is grow, I guess, will be the winner, and these guys will be losers. All right? You can tell fairly early on that the blue is not going to win, but as it goes. So this is a typical application that you would do, and we use real votes. So these are real votes from one of these Alaska elections in 2022. All right, and you can visualize that. Here's a little animated version of that same thing, rather than just showing it as a graph. You could have one of these trees that is sort of gradually evolving over time. This is a more needle-like thing. It's hard to make precisely a needle because this is sort of, there are 3 options, so it's hard to think about how to visualize this, but I think this came out nicely. I'll just mention the methods that we came up with are not only for this kind of live forecasting. It works really in any situation where there's some uncertainty in the votes, where you're not exactly sure what the votes are going to be, but you want to predict the results anyway. And we describe a totally different application to recount predictions. That is, if you do an election and then you decide for whatever reason you need to recount the votes, can we predict what's going to happen? Like, was the election actually close enough so that the recount might make a difference or not? And you can use the exact same algorithms to do recount predictions in this way. I'm going to finish up soon here. I just want to say this is really only the very beginning of this kind of work. The biggest limitation is that we assume that the probability distributions are independent. And what this means is, For example, if you have the A, which your prediction of A is something plus or minus something, and the B is something plus or minus something, when you say those two predictions are independent, or the uncertainty in each of those predictions is independent, what it means is the exact totals for each of them are unknown, but they're unrelated to each other. So whatever A ends up being is unrelated to whatever B ends up being. That is what it means when you say these two things are independent. But actually, in real elections, this is almost certainly not true because, for instance, if you have two candidates who are opponents, if you're not sure what it's going to go, but you find that A tends to be a lot higher than you expected, probably that means B is going to be a lot lower than you expected. There actually is some kind of correlation between them. So if I have an election, A versus B versus C, for example, and A and B are in the same party, we would expect that the predictions for A and B should move together. That is, they are not independent, but they are sort of moving with one another. If one of them ends up being higher than expected, probably the other one will also be higher than expected. All right? And if C is in the opposite party, it should also not be independent, but it should be kind of oppositely. We would say that in this case, the A and the B, we expect them in reality to be positively correlated with each other and negatively with the C, which is their opponent. Ideally, our method could be modified to incorporate these kinds of correlations, although this is something that we didn't attempt to do in the paper. Actually, our method does really model reality better in some of our other applications. So for instance, in a recount prediction, there is no reason to assume correlations in the uncertainty. So our method would work, without modification in that case. This is a little something we say in the paper. Our algorithm for deriving winning probabilities should be regarded as a sort of opening salvo. That was Nick's phrase, I like that. We are modeling the votes in the most mathematically simple way available. So this was our approach. As far as we know, nobody's tried to do anything like this before, and so we just sort of stripped everything down and tried to do the easiest possible mathematical model, which still ends up being a 30-page paper. So it is the simplest that we can make it. We understand that there are real limitations in terms of using this in certain situations in real life. That's what I just said. So we're going to leave the incorporating the correlations for another paper. All right, I think that's all. If you're interested, you can read the paper. That'll point you to it if you want to see it. And I will stop there. Thanks. Come at me, haters.
I have two actually. So the first question is, what does the ranked choice voting compare to the traditional European where you use two tours? So you have the first tour. I'm just curious about the outcome of the election. The first tour where you have all the candidates, and then you end up with the second tour where you have the first candidates. So.
And you actually vote again?
Yes.
Yeah.
So that, from a financial point of view, of course, is. So I think it could be fairly similar.
Yes.
As I'm thinking about it.
Mm-hmm.
But of course, it's not exactly the same because in the meantime, we could convince you and we could actually change.
Yeah.
That's classical,
Right.
I think, as far as I know.
Yeah, the ranked choice is also referred to as instant runoff voting. It's meant to simulate doing a runoff without actually making people vote again. Because you already asked them all of their other opinions, so you don't need to ask them to vote again. You can just use their other opinions.
Yes.
Yeah.
And another thing I was wondering, so when they make predictions, they are basing their predictions on polls. Can you have polls in this ranked choice? That is ahead of the
Yeah. So this is also something that we tried to have a very narrow focus in the paper. So the paper is presented as, if you tell me your results from the polls or something in a big chart of probabilities, I can do the computations to predict the winner. So we actually, Nick and I don't know anything about conducting polls or anything like that. But I'm not sure what you're asking. In real life, they do polls. Like there were polls in Alaska last week trying to predict the outcome.
But in basically, you need the poll to have the ranks. Because if the poll doesn't have the ranks, then you don't.
Yeah. Your poll you have to ask people what is your ranking? Yeah, not just who's your favorite. Yeah, right. Thanks. And by the way, I would like to acknowledge Professor Dumitrescu. She helped us out a little bit with some of the statistics. Neither I nor Professor Kapoor are real statisticians, so had helpful conversations.
Any other question? Okay, well, before we take the speaker again, if you want to bring this conversation to dinner, please let me know and we'll go to dinner. Thank you, Chris.
All right, thanks.